Good morning everyone and welcome to this Data Platform Summit 2020. I'm Davide Mauri, Program Manager in the Azure SQL team, and today I would like to discuss with you how we can create a .NET Backend API using Azure SQL, Dapper and other cool features that Azure SQL give us. And to make everything more realistic and close to what happened in the real world, we also have some twists during coding. So we will find a new requirement that we have to support after we already finished our coding, like adding new features or adding support to new properties, and actually also adding support to security after we created our API. This will be a very code-intensive session, so stay with me and let's start see what we have to do today. So what we have to do today is to create a REST endpoint that will allow our company to create a to-do service where user can subscribe and store their to-do list. Very easy application, actually also very well known because the to-do application is worldwide used to test front-end framework. And as you can see here, an example of a working one, and you can see the details on how you can experiment different JavaScript framework, for example, to create the to-do frontend on the todomvc.com website. But since this is a standard application, there is also a standardized backend that is defined in todobackend.com, where if you implement the API as the todobackend.com tell you, any of the available frontend will be available and able to actually call your API. And so that will make very easy and very realistic to create a real-world application where you have a team working on the front end, a team working on the back end, that they just agree on how the API that they will both use look like, and everyone can go on and work in parallel. Now, what we want to do is basically support this API that will be the definition in a few seconds, but our API is based on this JSON format that contains the payload of each to-do. So when the frontend creates a to-do list, will send us a payload like this. And of course, every time we have to return an active to-do to the frontend, our backend API should return something like that, right? So not especially complex, but good enough to represent a real-world scenario. Now, the specific requirements are that we have to support the get, post, delete, and patch operation. And if we have to return an array of document, we should return it as an array, JSON array, of course. But then if someone specifically asks for a item, so like for example, when someone could do get, to do, and passing the ID 1, in that case, we don't have to return an array, but just the specific document. So these are the very few requirements that we have to comply with. And it will be very nice to work on this project because the To-Do Backend API also provides you, and it's freely downloadable, a set of tests that you can use to make sure that your API are compliant with all the rules that we just, and the requirement we just received. So that's exactly what we will use. So let's move to coding, but also we have to keep in mind that we will start coding without having this knowledge. So we will start coding only with the requirements we just discussed. But along the way, new requirements will come. So one would be the ability, after we created our API, to add support for a new property. Actually, the order property at the beginning will not be in our requirement, so we will work without the order property in our first iteration. And then after we also add the order, we also want to add security to make sure that only the to-do list item that I create will be visible to me and not to someone else. Again, this will happen after we have created our code, deployed in production, And so it will be interesting to see with Azure SQL how we can deal with this agility that is very typical of startup or modern application, where actually we have some requirements at the beginning, but not all. And I really want to show you how Azure SQL can be flexible and supporting you in your agile process to go through all these typical challenges that we have every day. So let's move on and let's start coding. If you want to follow me while coding, you just need Visual Studio Code or Visual Studio 2019, .NET Core SDK, which comes with this product already, and Azure SQL if you just want to use the cloud, or SQL Server if you want to just do everything locally. Let's start coding. Okay, I'm using Visual Studio Code. So first of all, let's start creating the project. New web API, and let's give the name DPS 2020. So this will create a web API with a boilerplate code. We will just remove all the boilerplate code and then apply the code that we need and want for the to-do REST API. So let me get into the directory and then open the generated code. So what we need now immediately is two things. So first of all, we need to clean up the code to make sure that it doesn't contain the weather forecast code that is just, again, the example. And then also we want to add support for Dapper and the connection to Azure SQL. So let me do it straight away. So nice. Let's rename this to do controller, and then we probably don't need this, and also the HTTP GET will be a little bit different because we will be returning JSON. Okay, so let first of all add using system.text.json. And then here, what we will be returning is just a JSON document. A JSON document can be a full document or just an array. So here, a JSON element will be more than fine. And for now, let's just return .parse and then just an empty array for now. And then we want to return the root element. So just the array that I have created. We don't need anything here. What we will probably need is to add support to the configuration, so that we will store in the configuration the connection string. So we need to access the connection string at some point. So let's do private read-only configuration, and let's call it config. And the configuration will be passed in the constructor using the common dependency injection mechanism provided by ASP.NET. I just have to rename the class to do controller. And last thing, I just let's save this and just let's add the libraries that I just mentioned before in order to support connection to Azure SQL. So .NET add package Microsoft.data.sql client, and then we also add Dapper. Dapper is a micro ORM. If you never used it, it's very nice because it basically removes all the plumbing code that you need to do to execute a query on Azure SQL and map it to a POCO object or a JSON object in your code. So it makes your life just very, very easier. And so I really recommend to use it. You will have all the links and all the information, even a tutorial to learn how to use Dapper in the link in the slide deck. So make sure that to check it out if you never used it before. So let me add .NET, add package again, and this time Dapper, and we will be good to go. Nice. Now what we have to do right now is add the connection string, create database, create some object in the database to store the table, to store the to-do data into a table, create a storage procedure to return the data, and we will be basically good to go. Let's start creating the database. So I have connected to my Azure SQL server, and now let's create a database. Let's call it to-do 07 because I already created several examples on this to-do scenario. and let's do service objective, and let's create a hyperscale generation 5 to vCore, and that will be perfect. In the meantime, that database gets created. Let's finish let's finish the code here. Actually, here I forgot to store the configuration into an internal field. And then what I want to do is to store somewhere the connection string. So let me cut and paste some boilerplate code again here. That's it. So here I will have my connection string. My database will be 07, and as you can see, I'm using a specific user to allow the backend to connect to Azure SQL. Database should be almost created, usually takes a minute or something like that. So in the meantime, what I can start to do is add some code here to handle the connection to Azure SQL. So I will be using so first of all, system.data, and then using Microsoft.data.SQL client. So this new library that replaces system.data.SQL client. So make sure that you use Microsoft.data.SQL client in your project, because this is the future-proof library. And then let's add Dapper. Okay. Now here, what we want to do is actually connect to Azure SQL, execute a storage procedure that will return the to-do list or the selected to-do, and then return it as a JSON result, right? So we will be doing something like using, let's create a new SQL connection string, and the connection string will be taken from the configuration. So get connection string, we have called it Azure SQL, and that's it. Now here, what I have to do is just do something like var result equal con dot. So here our storage procedure will actually already return JSON. So our storage procedure will actually return just one value, so one table with one column and one row that contains the JSON. We just want to pass back to the front end, right? So this is a nice feature that Azure SQL give us, because Azure SQL completely supports JSON. So that will be very easy, because basically I will expect here to query something, but my query will return a single value or nothing, right? And my storage procedure will be called web.get_to-do, for example. It will support some parameters here that I will add here, and then here I will just need to specify that my command type is a storage procedure. Command type dot storage procedure. Perfect. Now, which kind of parameter I should pass to my storage procedure? Well, I know that for the request, for the specification of the backend API, that my get verb, my get method should be able to return all my to-do list, to-do item if I haven't specified any specific item, or the specific item accessed by the ID. So here I have to define my root on something like ID, optional, because this means that if the user specifies the ID, I will get the to-do by that specific ID. Otherwise, the user will not specify the ID, and I will return everything, right? So here I need to specify that I may get an ID, and now I have to define a parameter that may be there or may not be there. So to do that, Dapper allows me to use a nice class called dynamic parameters, where if my ID has a value, then I want to add something in my parameter, and my parameter will be like, let's say for now, the ID. It will be a little bit different, but let's say now the ID, and then we'll pass the value, right? That's it. And here, the only thing I have to do is that I'm saying to Dapper that this is my parameter. That's it. Now, what I have to do is return the result. And actually the result will be here a string, because Azure SQL will return me JSON, which is actually a string. And then what I want to do is return the, well, what I did here, basically. This, I just want to parse the result, right? Now, if the result is null, is empty, because there is no result to be returned, I want to return an empty array. Oh, yes, this is a task, so I have wait, and of course this will become async, and this will become a task. Nice. So everything will be asynchronous. I will query my storage procedure that will return a string that actually is a JSON. I will parse the JSON, or if the string is empty, I will just parse an empty array and return the result to my caller. That's it. That's done. Now we just have to create a database object and our API. At least the first alpha version will be ready to work. So let's create the database. I'm just using a prepared script just to speed up things. And then here I'm connecting to the database I created before. I will be creating a schema called web, where I will put all the storage procedure that I will be using in the backend API. I will create the user that will be used to authenticate the backend API against Azure SQL. We make sure that this user can read from all the table and can execute the storage procedure in my web schema. Then I will create a sequence to generate numbers, and then let's create my first table. Now, the to-do table to start with won't have the order, because we said that we start with a very easy approach where we don't know that we have to support also the order column or the order property. So let's create the table to do just with the ID, title, and completed, the basic thing to store a to-do item. Now, what I would probably normally do here is create a storage procedure. Actually, let me just take that as an example, and then specify as a parameter an ID, right? But if I do that, what will happen is that I only have the ability to specify exactly one ID. What I want to do here is to give some flexibility to my API, to my, in this case, storage procedure, so that the developer creating the API can decide to pass or one ID, just one ID, or an array of ID. Now, how can I do that? Well, the trick is to actually use JSON also as an input, because if I do something like that, so let me create a variable called IDs, which is an varchar that contains something like that, an ID here, and then let's say 1, and then close this object, and then open another object, ID 2, for example. Okay, so that's a valid JSON. So what I can do here is something like select from OpenJSON. That's the function that will allow us to manipulate JSON in Azure SQL. So I can do something like ID. This is I just want to process my JSON, right? But then I want to specifically extract the IDs from there. So what I have to do is ID int. That's it. I just have now the ability to receive an array of ID, for example. So instead of creating a storage procedure that accept just an integer, so a scalar, I will create a storage procedure that accepts a payload, a JSON, and internally I have to remember a little bit about the requirements that to-do backend asks me to implement. So if I don't specify any ID, I will return all the to-do, right? So this is exactly what I'm doing. If there is no payload specified, there is no JSON specified, no ID specified, I will return everything as JSON, because also Azure SQL can return my results set not like a table but like a JSON. So let me for example add a couple of to do in my table here. So let me add to do 1 and to do 2. Of course, I don't have to specify the order at the moment. Nice. And if I do something like that, I will just have the regular table. If I do for JSON path, I will just have one scalar, a string that is also a JSON. So that's exactly what we want, right? So if I don't specify any parameter, I will return all as JSON. If instead I specify a parameter that is a JSON, first of all, let me check that it is a valid JSON, so we don't have any problem with malicious parameters values. And then all I have to do here is just to again return all my to-do whose ID is actually within the JSON that has been passed to me as a parameter. Very easy. So I can create my storage procedure right now. And if I execute my storage procedure, I will be able to or get everything as an array, or let's say if I specify correctly my JSON here. So id, I just want to have, let's say, the ID 1, okay? That will return to me the ID 1. And just to make my life easier as a coder, at least the storage procedure will always return an array, no matter if it contains only one object or a set of objects. For example, if I specify here something like that, so I will specify that I want to have ID 1 and ID 2, this will return an array of two objects. The bottom line here is that the storage procedure will always return a scalar that is a JSON that is actually a JSON array. Now with that, I can know that my storage procedure here will need to have a little different value here, right? Because I need to specify the payload here, not ID, because my parameter here is named payload, and the payload must be something like that, right? So what I need to do is to create very easily, if an object that is actually can be serialized into an object like the one, a JSON like the one I just shown you. So P will be an object that contains just an ID. And so all I have to do here is to serialize my parameter. That's it. So let's give it a run and let's start this. Now to test my endpoint, I will use Insomnia, which is a nice free tool to execute REST APIs. Let me create everything needed by Visual Studio to execute my endpoint. Press F5 and let's debug this. You will see that .NET Core will start to listen to a couple of ports. The one that we will be using is this one. So what I can do here is something like that to do. So let's see if I did everything right. Perfect. So here we go. We have our working endpoint. If I specify 1, I will just get the first item. Now, there is an issue here. As you see, we are always returning an array, right? We don't want that because the requirements are that if I specifically ask for an item, I don't want an array, I just want that item. So to do that, I have to do something a little bit more complex. And also, if you remember, the specification also specify and requires that we have a URL here that will look something like that, that basically allows us to reach that specific item. So we need to add a URL element here that actually points to that item. So it will be something like localhost /5000, and that will be to do 1. So I have to generate this URL at runtime, just adding the host where my API is hosted, the route to the API, and the ID. Pretty easy. Doesn't really make sense to do this on Azure SQL, even though we could, because Azure SQL can manipulate JSON pretty easily. But this is really a typical work that should be done in the backend. So what I'm doing here is actually using a function, a method that I already prepared, that I called it process result. And this process result basically makes sure that we do two things. First of all, we add the URL. And second, we make sure that depending on what kind of request has been made to our API, here we will actually return an array, or, so this is my result. So what we want to do here is to return an array if the user didn't specify any ID, but return an array when the user didn't specify any ID, right? So let's see if I did everything correctly. And yeah, this process result method just do exactly what I described to you. So it's really not anything special here. So let's just run. And of course, you will be able to take the look at the code yourself because everything is published on GitHub. So if you are interested in how can I do everything that I just said, just take a look at the code. But the result is that if I specify a generic to do, I will get an array of objects. If I specify exactly one ID that I'm interested into, I will exactly get an object. And as you can see here, I've injected the URL that allows me to navigate to this specific URL. This is a requirement that has been specified in the backend API. Okay, nice. Basically, it's almost done, right? What we can do right now is start to use the provided test to make sure that the work I'm doing on the API is compatible with the requirements. So let's add a new folder to my workspace, and specifically I have downloaded here the to-do backend JavaScript specification that are the tests that I can use to verify that my backend API are working as expected. Now, since my test here, actually the test that has been created by the developer of the backend API website, need to call my endpoint and they will be running on another server. So for example, if here I downloaded an extension called live server, okay, that basically allows us to execute a server within Visual Studio that will serve a HTML page. So what I can do is right click here, run open with live server, and that will open up this page. And here we go. That basically allows us to do something like that, localhost, and then I will be able to run my test. Now, we have an issue here, as you probably know, because my localhost at 5500 port will try to execute an API that is not within the same domain, basically, or host. So we need to execute what is called a cross-origin request. And to do that, I need to add some code to my startup in order to make sure that course is configured correctly. So I need to add course to my configure services here, saying that I would accept request from that specific origin. And then I just have to also, after routing and before authorization, make sure that I use that origin. Otherwise, I will get some error. Now, just let me show you what happens if I don't do that. So let's start the debugger and see what happens if I execute my test suite against my endpoint without course enabled. So let's go here. Nice, and you will see that yeah, we have some issue around course, right? So to solve this issue, we have to do two things. We have to enable course, and also since we just configured localhost 5500 as allowed origins, we also need to remove the HTTPS redirection, because otherwise we'll be redirected to HTTPS and that will not be the same as this one. Now let's try to do this again. And now everything should work nicely. So let's go back here and very nice. We can actually issue the get and everything is working. Now, of course, we need to implement a post, implement a delete, and just make sure that we have the root URL as we already did. So we just have to implement following the requirements, the delete method, the post method, and also the patch method. Let's do that. Now, to stay within the hour that I have available for this session, I will do a little bit of copy and paste right now, because I already have prepared, of course, the method and the storage procedure used to implement the REST endpoint. So let me do that, and in the meantime, let's also take a look at what I'm doing. So here we go. So what I'm doing here is copying a method that will allow HTTP post method to be invoked. What I'm doing here is very similar to what I'm doing for get. So I'm opening the connection, creating a dynamic parameter exactly as I did before, calling a storage procedure that in this case will implement a post, which means that I will be able to insert my data into my table, and then I will return the result, again, usually following the usual requirements. And then the delete is very easy, because if the user specify a specific ID, I will delete that specific to-do. Otherwise, if the user doesn't specify ID but just call a generic delete, everything will be deleted. So the parameter here, the payload, is very similar to what we did for the get. And the only particular one is patch, because patch means that we want to specify, of course, an ID that we want to change, a to-do that I want to change via its own ID. So we will have two parameters here, the ID of the to-do we want to change, and the payload, so the new content for that to-do. So what I'm doing here is I'm creating a JSON object that in the ID will have the ID of the to-do to change, and in the to-do section that will be an entire JSON object that contains the new information for the to-do. And then I will call the storage procedure. So this is done. Nothing very, anything is too much different than what we did for the get. What is interesting is the code in SQL side. So let's go back to the object that I have to create. So we already created a to-do. Now, how the post will look like. So the post means that as a payload, I would expect to have a JSON that I have to use to insert data into my table. So the post would probably be something like that. Of course, I don't have to specify the ID because that will be provided for me. And that's exactly what would my post look like. So a title completed, and that's it. Everything needed to store the JSON. Actually, this is not completed because I'm doing it. So let's set it to false. So this is the payload that I have to be able to manipulate in Azure SQL. And this is exactly what I'm doing here. So I'm just checking the payload is JSON, and then using OpenJSON, I'm extracting the title, the completed bit, and the order. Now, we said that the order is not something we know at this moment because we are pretending we don't know we have an order property also. So let's remove that. Let me create the storage procedure. And of course, I have to remove the order also from here and from here. Nice. And also, once we have inserted the data into my table, I also want to return the newly inserted data. So I'm just calling the storage procedure I already have created before to return the JSON of the newly inserted to-do. So let me create that. Nice. To-do is very similar, so it will accept, as said, the target to-do that we want to update, and then the new value for the to-do. Again, here I have to remove the order because we are, again, pretending that we don't know that we have to add the order. So let's do that. And as you can see here, I'm basically using, again, OpenJSON to read the data that I need to change and then do the update. Now, if a user didn't specify the title, we want to remove the title from the JSON or from the data I already have. We just want, when the user don't specify the title, it probably implies that they don't want to change the title. So if they don't want to change the title, we will use calls to get the existing title. Otherwise, we'll get the new one. This is very nice way to easily implement a patch using also JSON. So let me create the patch procedure here. Nice. And the delete will be the easiest one, because if we receive a payload, we will delete just that specific ID that is specified in the payload. If the payload is empty, we will just delete everything. That's it. Now, that should be it. If I hadn't made any or add any error or mistake, that should work, because the patch will call patch, delete will call the delete procedure, and so on. So let's just do something very typical in an agile development. Let me start the endpoint, and the live server is still working. So what I can do is just go here and just try to run all the tests. And let's see how many tests I pass and how many tests I don't. Okay, oh yeah, here I forgot that I need to clean up my table because I was doing some test. I added some data before that should not be there. So let me completely clean up my to-do and let me run this again. And that, oh, very nice. So all the API are now working as expected, are adherent to the requirement. So I'm able to post something, to delete something, after check that after I delete, the result is a empty array, and so on. So in theory, our first version of the API is done here. We can already move on, publish this, and my to-do MVC, any of these front end, let's take my favorite with Vue, will be able, if I connect that front end to my endpoint API, to actually use my endpoint API to store, retrieve, delete, and update my to-do list. We can simulate that using Insomnia. So let's do a get of everything right now. So this is what exists right now in the table after the unit tests have been executed. So let me, for example, delete 27. Nice, and now let's do a get, and that should not exist anymore. Perfect. Now let's post something. Let's post that I'm working on my or code sample right now. Nice, this is ID 29, so I can go here, do a get, ask for the 29, and I will receive exactly this, or otherwise I can receive everything, or I just want to patch, and I just want to say that the ID 29 is now completed. Very nice. And let's see what we have on the Azure SQL side. So if we go here and do just a select from my to-do, you will see that, very nice, this is the to-do I posted in JSON. Thanks to the fact that Azure SQL is able to natively manipulate JSON, I decided this time to convert my JSON into a table. I could have also stored JSON as is. And then would open other option to make my endpoint really easy extensible. But you will see that now that also extending this endpoint to add, for example, support for the order, because we just discovered that there is this new requirement that we have to support an order field. It's pretty easy. Now let me show you how easy it is. Let me start the counter, okay? You should be able to see, okay, it started. I want to see how much does it take in Azure SQL using a regular relational table to extend the schema so that it can easily support the order. So in order to do that, all I have to do is go to my table, alter table, dbo.todo, add, and let's say order, and that will be an integer, and of course it should be nullable. Nice. So first of all, I can easily add a new column to my table as long as the content is null. It will not take any amount of time. It will be just a metadata operation, so it will happen almost immediately. Now, the only thing I have to do is go to my storage procedure and just make sure that they know that there is a to-do, an order here, right? So let me do order, nice, and now that will also be added here. So this is done. Now I need to change also the post, done, and also this here, that will be an integer, and that is done too for the post. And oh, I forgot something here. Nice. Okay, let's do that. Now the patch will be very similar. Let's add an order here. Also, I receive as part of the JSON an order that I need to take care, and I want to add order here. And if the user specify an order, I will replace the order with the new value. Otherwise, I will use the value that has been already stored in the database. Oh, I made a huge mistake here. And I'm going slow. That's fine. Order, okay. It's not easy to write code and talk, I tell you. But that's it. Let's see if I did everything correctly. There is a comma here that should not be there. Okay, fine. And of course, delete doesn't need any change because it doesn't work on column. Okay, I didn't even restarted my debug, right? So this is already still working. So if I if I now do a get, and I would expect here to, actually, there is no order here because I never specified one. So let's do this. Let's do patch, and let's say order equal 1. And perfect. So order is now stored in my database. I can go here, select to do, and I see that order is stored. Perfect. I can go here in my test, run the test again, and let's see if now order is correctly managed. Done. Let's see how much did it take. 3 minutes. While I was talking, while I did some mistakes, so probably, let's say 2 minutes, it's a little bit more realistic. So in 2 minutes, you were able to see me adding a completely new, unexpected property in Azure SQL without basically doing anything complex. So this is the proof that extending a schema is really easy. Now you can even make it easier if instead of just storing the JSON as a table, you also store the JSON as JSON. I will send the link to another GitHub repo where you can just play with this idea. But this is just to show you that Azure SQL is absolutely easy to extend and will support any of your agile needs. If you need to live with a schema that is always changing, you don't know the schema in advance, the schema may change. So there are very many options you can use, and this is just one to make sure that your schema is dynamic enough to support your agility, right? So just to debunk this myth, because I know that many think that only NoSQL database are good for agile approach. This is the proof that also Azure SQL is perfect for agile approach. Now let's go back and now make something very, I wouldn't say complex, but still more challenging. Let's add security to my example. So we just deployed the updated API with the support for the order property. And now we receive a new requirement. We have to make sure that the to-do that someone insert are visible only to that person, right? Because now there is no security at all in my system. If I create a new to-do, anyone will be able to do that. And the new requirement is that only the owner of the to-do should be able to do that, should be able to view that to-do. And it should also be possible in future to allow someone else that I choose, so that the owner choose, to view that to-do too. So I, as an owner, I will be able to view my to-do, but also share my to-do with someone else I choose. Now, how we can implement that with the minimum amount of code? The solution here that I have chosen for this session is called row-level security. So row-level security is a feature that is available in Azure SQL, and it's pretty unique, I must say, because without touching the to-do table, so without making any change to this table, we will be able to apply a security policy that will make sure that only the owner of this ID, for example, or this to-do, will be able to see that to-do. All the other, even if they will run select from to-do, they will see an empty table or only the to-do that they own. So to do that, let's start and take again some code here that I already prepared just to speed up again everything. We just have like 20 minutes left, so just want to make sure that we can spend the time understanding exactly how this works. So let me make sure that everything is in the correct configuration. Perfect. Let me create a new schema, just as a best practice to store everything related to row-level security. And here I will be creating a new table called to-do permission, where I imagine that at some point in my front end, there will be an authentication method. Could be, you know, Azure Active Directory, integration with Facebook or Twitter, any single sign-on solution you might want to use. And that solution will actually return to me a unique ID or an email or whatever that allows me to uniquely identify that user. In that case, I'm thinking that I will receive a user hash ID. So I need to store that user hash ID that represents the authenticated user by the front end somewhere. And I need to associate that with a specific to-do item that is probably the item that he will create or that he will be, the one allowed to see. And then I want to specify if he can access that to-do item or not. That's it. So let me create this table. And then I will create something else, a function. This function accepts as an input the ID of a to-do, and based on that ID, it will go in the table I just created and check if the user with that hash ID that is looking for that specific to-do can actually access that to-do. So here I commented out something that we will discuss a little bit later, but let me just create this for now. Now that we have created a function that basically allows Azure SQL to understand for each row of my table that contains the to-do, if that to-do should be allowed to be visible to a specific user given the user hash ID, we just have to create the policy and ask user to and ask Azure SQL to apply the policy. So that's how we do it. Create security policy, add filter predicate and the function we have created using the column from the table to do, the column ID as an input for that specific function. So this means that every time someone will try to access using, for example, select from my table to do to that table, the security policy will kick in, and for each row that the user is trying to access to, the function will be called. The ID, the column ID, will be used as an input for that function. If the function will return 1, then the user will be allowed to access the row, otherwise not. Now, it seems a little bit complex, but actually it's very easy. So let me create this, but let's keep this off, okay? Nice. Now let's go here. I also have prepared already a nice example, I think. Let's clean up everything. And let's insert some new to-do. Now, let's say that I connect to my database and I select everything. Nice. I can see everything. I created the policy, but is not enabled. Now let me enable the policy right now. Let's try to do again. Select start from to do again. Now it's empty. The table still has values inside, but I cannot see anything because no one gave me the permission to see that specific rows, right? So let's disable now the policy again. And let's try to add some permission. Now the table to do permission is empty. So let's say that I want the user 1234 be able to access the to do one, because remember the table we created needs the user ID, the to do ID, and if that user can access that to do. So what I'm doing here is saying user 1234 or the hash ID user 12345 should be able to see ID 1, the to do with ID 1, and yes, it is able to do that. 1 means it can access. So let me do that. Now let me enable the security policy again. Let's go here, and still I can't see anything. Why? Well, because Azure SQL doesn't know I am the user with the user hash ID 12345. Now I have to find a way to tell Azure SQL that I'm that user. So there is this new system procedure here that allows us exactly to do that. It allows us to inject into the session a context value, which is basically a key value pair that can be used within the function, and this is exactly what we did before, session context, to extract that information from the context. So here I'm saying to my Azure SQL, look, the user that is now active in that connection is the user that can be identified by user hash ID and 12345. So let me add that. Now, if I do select from to do, Azure SQL understands I am the user 1235, and the user 1235 has access to the ID 1 for the to-do table. So here I will be able to see my to-do. Perfect. Now this means that I can use that session context to actually communicate to Azure SQL which user is accessing the database, even if the real user that my backend API is using to authenticate against database is always the same. So is always this, let's see if I still have the code around here. Yes, it's always this to-do backend user. So basically the to-do backend user is actually authenticating against Azure SQL, but once the authentication has been done, the to-do backend user will actually send information about the real user, the real end user, using the to-do solution that has been authenticated using I don't know, Twitter or Azure Active Directory or any single sign-on tool, and it will authenticate using that single sign-on service. The result of that single sign-on will be an ID, and I will pass that ID to Azure SQL via the session context. And then I will use the session context with the security policy to make sure that that user can only see the to-do that he is authorized to see. Now, why this is special? Because this storage procedure is very interesting because it has a parameter called read-only. And now here I set it to 0, means I'm not using this feature, but I will be setting it to 1 when I will be using it into the code of the backend API. Read-only equals to 1 means that once this value is set, it will not be changed, or it cannot be changed for the entire duration of the connection. So this means that after we connect to Azure SQL using the to-do backend user, we immediately set this context with the user hash ID we got from the single sign-on framework we are using. And after that, all the subsequent execution for that connection will be executed having this session context available, and that session context cannot be changed anymore. So this allows us to safely pass information about like the user ID in this case to Azure SQL without actually changing the user authenticated against Azure SQL. This allows us to keep connection pooling working, and connection pooling is vital for great performance, for scalability. So we don't have to change or manage the connection pooling in some strange way that will disable or diminish the scalability and the performance of our API, but still we can securely pass information about the user to Azure SQL, so we can use it to make sure that we only return the data that the user should see. So that's very nice, right? And now let me let's keep this enabled, right? Let's keep this enabled, and let me go back to the code, do some changes, and add this feature to the backend API that we have been creating so far. So let's stop this. So there is only really one thing I have to do here, and let's just focus on the get method because all the other method will be very similar. So I need to open a connection manually here. So that will be await con.openasync. And then what we want to do is just execute this procedure before anything else, right? So I already have prepared the code, and here we go. So I will call this procedure, making sure that I am telling that I'm passing the user hash ID and that the user hash ID. Now, user hash ID, let's say for now equal 1, 2, 3, 4, 5. Okay, let's do that. But ideally, you will receive the user. Actually, let's do that. I already have the code. I will just copy and paste this, but I won't go into detail. So what I'm doing here is getting the user hash ID from a token that is given to me by the JWT token, right? So I'm using JWT token to securely store the information that the single sign-on authority gave to me. So in order to do that, I need to add a couple of libraries, a couple of namespace here. So I need this. the system identity, the JWT token. Here we go. And I also need to add this one. Let's go back to the terminal. Go and do .NET add package and this package here, the JWT bearer token. Now, once we have that, there's a little bit more code need to write, but that's not specific on Azure SQL or row level security. Is more specific on how to handle properly a JWT token. So again, you will have all the code, so you can take a look at it. The sample is fully functioning. But basically, what it does is that it allows us, and actually I have to also do a couple of things here. This needs the namespace called authentication, and this needs the namespace called claims. Okay, so the JWT security token will give us securely the information on who logged in our system. In this case, the only information I'm interested in a claim called security ID, that is the user hash ID that I want to use. So now what I can do is I can go back here. Instead of using this fixed value, I can just call the function, right? Now I already have changed a little bit the code in order to correctly handle the JWT token. Now what I'm interested into is showing you how you can use it, right? So I have already generated a JWT token. Here you have the full code that allow you to generate a sample JWT token. Again, probably usually you will receive from an authentication provider, but it's nice to have a easy way to generate a JWT token. And what we have to do, actually, I already have prepared here. So this is the JWT token that has been generated for me. So here I have my claim, my security ID, that is exactly 1234, right? Now I can just take this JWT token, and if I now execute my my endpoint that calls the get storage procedure behind the scene here, you will see that it doesn't return anything. Now, if I go to authentication and specify the bearer token, and here specify my JWT token, now I will be able to see my to-do, right? And now, if I want to go here, let's see. Okay. Now, if we take a look at the table, we know that let me disable the row level security. So let me disable this. Now we know that we have two to do, right? But we have only seen one because the row level security was enabled. If it is disabled, I can see everything. The moment I enable it, there is no way, unless I specify in this case via the backend API the ID that will be then used as a parameter to my set session context procedure, the card value for the user, and only in that moment I will be able to see the to-do that I'm allowed to see. And as you can see, this is really amazing. There is no changes done to the to-do table. All the changes happened on a function, on an additional table, the to-do access to-do permission table, that allows me to manage security on a side without touching my table. So here I have another option. Of course, I could have added more column to my to-do table to manage security there, but maybe I can't. And if I can't, with Azure SQL, I also have this ability to use the row level security using the same table, using an additional table as I just shown, so that I can be absolutely sure that no matter what happens, only the data I am authorized to see will leave Azure SQL and reach the backend. This is super secure because this means it's not that I'm moving all the data from my Azure SQL, put it into the backend, and on the backend I'm checking if I can see something or not. No, there is literally no data going outside Azure SQL that is something that I'm not allowed to see. Only the data that I'm authorized to access to will be leaving Azure SQL. So this is really amazing because allows us to create a secure API with a very minimum effort, but yet very high security. And this works with any language. So it will work with .NET, Python. I have also an example, Node, anything, because we just have to call a storage procedure and that's it. So this is very, very nice and beautiful, in my opinion, honestly. So here we go. I can only see what I'm allowed to see. If I don't specify an authentication or I specify another user, I won't be able to see anything. For example, if I go here, generate another token with 6, and I use this, I will still be authenticated, but the user 6 doesn't, 1, 2, 3, 4, 6 doesn't have any authorization to see anything. So I will still not be able to see anything. If I want to allow the user 1, 2, 3, 6 to see something, I have to go where? Let's see. Here, add that, and let's say I want to user 1, 2, 3, 6 to see the item 2. Now let's go here. Here we go. Really amazing. Thank you so much for watching this session. I hope you enjoyed it. I really enjoyed it doing it. It has been fun coding and speaking and recording the session. Make sure to download the slide. The slide will have all the details, all the links for you to learn about Dapper, to learn about the to-do REST endpoint, to learn about row-level security, JSON, and also, of course, the link to the GitHub repository where you will find everything that I just shown, even with more details, because I will go into details of the JWT token with, some README. And that's it. That concludes the session. I will be online for question and answer. See you next time. Bye-bye.